Hey Geometry, it's Friday. We're gonna start into section 2.7 today. We're gonna go over this again on Monday as well, just because what we're gonna talk about in this first little box here is super important. This first box just gives us some terminology that we all need to know so that going forward we can talk about angle relationships. So, these, let's see, there's six of them. There's these six different angle pairs, I guess, that we have to talk about, occur when we have three lines that are intersecting. So these two, and then this, we have one line that's going through two other lines, okay? So the one line that's touching both of the other two lines, this guy is called a transversal. Okay, so transversal. So that is the only line that touches the other two lines. Yes, these two might intersect over here, but just looking at the two intersections that we have, this transversal, the one that goes up and down, is the only one that's touching both of those, okay? And then within that, we have two kind of intersections that are happening, okay, which creates 8 different angles, okay? And then those 8 different angles make up pairs, okay? So when we talk about the two lines and then the transversal intersecting them, the first thing that I tell kids to do is find where like the inside of the train tracks live. Okay, so if these two lines are going kind of side by side, this would be the inside of the train track. Okay, so they call that the interior, and then everything on the outside would be the exterior. So exterior is over here and over here. Okay, so in the lane is that middle part. Okay, so any of the angles that are interior angles are going to be these ones on the inside. So 4 and 3 and 5 and 6, those are all going to be interior angles, like it says here. Okay, the exterior ones are the 1 and 2 and 8 and 7. Okay, those are on the outside. All right, consecutive interior angles. Okay, let me erase some of this stuff so we can write. Okay, we have these 3 lines. Okay, and the transversal going between them. Consecutive interior. Of the interior angles 4, 3, 5, and 6, consecutive means on the same side. So if here's my transversal, 2 of them that are on the same side that are interior are 4 and 5. 4 and 5 are a pair together. 4 and 5 are a pair together, and then 3 and 6 are both on the same side of the transversal. They're both on the right side, and then they're inside. Okay. Then we have alternate interior angles. So we're still talking about interior, these guys, but we're talking about ones that are on opposite sides of this transversal. So a pair of angles that are on opposite sides that are on the inside would be 4 and 6. Those guys are on opposite sides of the transversal. And so 4 and 6 is a pair, and then 3 and 5 is the other pair that's opposite each other. Okay, so those kind of go together. Okay, alternate exterior. Okay, the exterior ones are 1 and 2 and 8 and 7. So we're talking about like which one is alternate from angle 1. That would be angle 7. That's on the outside. Okay, and then 2 would be a pair with 8. Those are alternate exterior angles. They're on the outside, and then they're on opposite sides of the transversal. Okay, and then the last thing that we have are corresponding angles. So they're kind of in the same position relative to the intersection. Okay, so if I look at this intersection and this intersection, angle 1 is in the top right corner, and so is angle 5. Angle 5 is also in the top right corner. So 1 and 5 goes together, okay? Angle 2 is in the same position as angle 6. They're on the top, did I say top right corner? Top left corner is what 1 and 5 are. Top right corner is 2 and 6, okay? Bottom right corner is 7 and 3, so that's a pair. And then 4 and 8 are in the bottom left corner, okay? So each one of those is an angle pair relationship, all right? We're going to go over that again on Monday because that's superly important to remember each one of those terminologies, okay? So down here, they want to know what each one of these pairs is according to these vocabulary words up here, okay? So let's first outline of these 3 lines. I have the purple one, the red or the pink one, and we'll call this one the blue one. Okay, of those 3 lines, which one is the transversal? That is going to be the blue one, transversal. This one is the only one that touches both of the lines, or both of the other two lines. So that's the only line that is intersecting both of the lines. And then we have two intersections here, this one and this one, which creates 8 different angles. Okay, so let's talk about these angle pair relationships. 1 and 5, angle 1 and angle 5. Okay, if here's my transversal, those guys are on opposite sides of the transversal, so they are alternate, and then they are, if this is the interior where my train track lives, okay, these guys are on the outside. So these are alternate exterior angles, okay? Part B, 6 and 7, 6 and 7. Those are on the inside, so those are interior angles. But since they're on the same side of the transversal, they are consecutive interior angles, okay? Let's go to part C, which is 2 and 4. 2 is this angle, 4 is this angle, okay? Those guys are kind of in the same corner of the intersection. They're both like on the right side of the intersection, 2 and 4. So 2 and 4 are corresponding angles, okay? Another way that I can remember that they are corresponding is if I try to go through here and talk about 2 and 4. 2 and 4, one of them is interior and one of them is exterior. That's the only time that you will get corresponding angles, right? If here's my interior, angle 2 is on the inside, but angle 4 is an exterior angle. That's the only time that you will end up with an angle pair that has one interior, one exterior, okay? And then the last one is 2 and 6. Sorry, I'm doing a lot of erasing. 2 and 6 are on opposite sides of the transversal. Okay, so they are alternate something, but here is the interior of the train tracks. So 2 and 6 are alternate interior angles. Okay, all right, so those are those angle pair relationships. The next thing it talks about is parallel versus skew. So parallel lines are coplanar lines that do not intersect. Okay, you should maybe probably know what parallel lines are. And then skew lines are lines that are not going to intersect each other. So a lot of times I talk about, like, let's say here is our classroom. Okay, I'm going to try to make this like 3-dimensional. Okay, so here, the top part up here is like the ceiling. This is the corner of the wall, and then here's the baseboard at the bottom. Okay, skew lines would be like this line over here and this line over here. This line is not ever going to touch this line, because they're just on different planes, I guess. Those are going to be skew lines. And then parallel planes are two flat surfaces that are one above the other one. So parallel lines, this takes us from one-dimensional into being two-dimensional. So they are parallel planes. Okay, let's go down to the next one, the corresponding angles postulate. If these two lines are parallel, okay, if these two lines are parallel, and we know that they're parallel by the way that they mark them, they put little arrows on each one of them. So these little red arrow marks on that tells that those things are exactly parallel. So as long as those two lines are parallel, and I have corresponding angles, the corresponding angles will be exactly the same measure. So I'm going to mark these in different colors. One set of corresponding angles is angle 1 and angle 3. They are both in the top left corner of the intersection. So if angle 1 is 130 degrees, angle 3 is also 130 degrees. Okay. Angle 2 corresponds to angle 4 because they're in the top right corner. So that one has to be 50. And this one has to be 50. Okay, I'm going to bump down to 8 and 6. Angle 8 and angle 6, those correspond to one another. And 8 and 6, since they are vertical angles to 2 and 4, they're across the intersection. You remember from last set of notes that we had that vertical angles are the same. So these guys both have to be 50 degrees. And then 7 and 5 are corresponding angles. Those are vertical angles with 130. So each one of those is going to be 130 degrees. Okay, so this only works if these two lines are parallel. Okay, so if I bump up to the last diagram that we had, like here, okay, corresponding angles were like angle 1 and angle 3, right? They're both kind of in the top corner of the intersection. But since these two lines are not parallel to each other, you can't tell me that angle 1 is going to be the same measure as angle 3, right? Angle 1 looks like maybe it's 80 degrees because it's less than a right angle, and angle 3 is more than 90 degrees, so maybe it's like 110, okay? So this only works if the two lines are parallel, like these two are, okay? So use the corresponding angles postulate. Let's find what all these other, I didn't need to erase that. Find what all these other angles are. The measure of angle 5, it says, is 72, so that's what I'm going to put here, 72 degrees, okay? Find the measure of each angle and tell which postulate or theorems you used. So angle 4, all right, let's talk about angle 4 in relationship to angle 5. 4 and 5 are those corresponding angles because they are in the bottom left corner of the intersection, okay? So this guy is going to be 72 degrees as well, and that was because they are corresponding angles. And I'm going to put in parentheses with the angle 5. It's a corresponding angle to angle 5, okay? And then we have angle 2. Okay, angle 2 doesn't really have anything to do with, well, I guess he's kind of an alternate exterior angle with angle 5, but more specifically, he is across from angle 4. He is a vertical angle. So vertical angles theorem, we wrote that down on our theorem sheet. Vertical angles theorem says that if they are vertical, if they're across from each other, then they are the same measure. So it is a vertical angle with angle 4. So its measure is 72 degrees as well. Okay, so each one of these, maybe we should mark that. This guy is 72 degrees, and this guy is 72 degrees. Okay, now we could go around and say like angle 7 has to be 72 as well, because he's across from angle 5. And that would mean that each one of these other spots here, like if I look at this being a straight line, 72 degrees is what this one is. But then this one has to be the remaining of that, so that it makes up that straight line of 180, right? So this would have to be like 108 in order for these two angles together to add up to be 180. But if angle 1 is 108, then angle 3 has to be 108 because those are vertical angles. And if angle 1 is 108, then angle 8 corresponds to angle 1. They're both in the top left corner of the intersection, so that one's going to be 108. And then angle 6 is vertical to angle 8, so that's 108 as well, okay? Now, there's kind of a trend that goes along with this, because if you have lines that are parallel to each other, okay, and you have a transversal going through them, you will only ever have two angle measures involved, okay? And then that one angle measure, like 72 degrees, is represented with 4 different angles, okay? And then you'll have 4 different angles that are the other. They are 108, okay? So you'll have 4 angles that measure 1 degree and 4 angles that measure the other degree, as long as you have 2 lines that are parallel and a transversal going through them, okay? All right, how much more do we have left of these? Oh, we don't have too much more. Okay, so parallel lines and parallel angles, the alternate interior angles theorem. Angle 1 and angle 3 are alternate interior angles. And what happens with that is angle 1 and angle 3 will end up being the same measure. So let's say angle 1 is 120 degrees. Angle 3 will also be 120, kind of like up here. You know, 108 and 108, those were alternate interior angles, so those were the same. If angle 1 is 120, then that means angle 4 has to be 60, okay, because those have to add up to be 180. So if angle 4 is 60, then angle 2 has to also be 60. Alternate interior angles, they are congruent to each other, okay? Consecutive interior angles. The ones that are consecutive are the ones that are on the same side of the transversal. So angle 1, the one that is consecutive to him, is angle 2, okay? Angle 1 and angle 2 are consecutive. Now, those two measures are not the same measure, but what they are supplementary angles. So they add up to be 180 degrees, okay? So if I use the same measures of 120 for angle 1 and 60 for angle 2, those two add up to be 180, okay? In the same way, if angle 4 is 60 and angle 3 is 120, those add up to be 180 as well, okay? Alternate exterior angles would be like angle 5 and angle 7. And let's say angle 5 is, I don't know, 70 degrees. Okay, that means angle 7 is also 70 degrees. Okay. Angle 8, then would be 110 degrees because those add up to be 180. So angle 6 is 110. Okay, and that's just for alternate interior angles. Those are congruent. Okay, so the way that I teach the kids this is that if they are alternate to anything, like alternate interior or alternate exterior, no matter what, they're going to be congruent to each other. Okay, so if they're alternate exterior angles, they're congruent. If they're alternate interior angles, they're congruent. That's just kind of the way that that works. Okay, this is a proof of that alternate interior angles theorem, so we're going to skip that. Let's go down to example 3. Reading Lane and Creek Road are parallel streets. That's important. We need to know that these two guys are parallel to each other. All right, it says if the measure of angle 1, this angle right here, is 118, find the measure of angle 2. Okay, Park Road is the one that goes through them. What's the name of this line called? Okay, he is a transversal. Okay, so they're giving us angle 1 and they want us to find angle 2. So angle 1 and angle 2, let's figure out what relationship those two have to one another. They are on opposite sides of the transversal, but they're both on the inside of this little lane right here. So they are alternate interior angles. And that means that if angle 1 is 118, angle 2 has to also be 118 degrees. So 118 degrees. And the reason why is because they are alternate interior angles. Okay, let's go down to the next one. This one is a little bit trickier because they have equations for us to do. So the measure of angle 4 is 2x minus 17, and the measure of angle 1 is 85. Okay, so there's a couple different ways that I could do this. Let's say, okay, if angle 1 is 85 degrees, then that means that angle 2 has to be the remaining amount to add up to be 180, which I think is 95 degrees, right? Okay, but then angle 2 and angle 4, what do those two have in relationship to each other? Well, 2 and 4 are both on the top right corner of the intersection, which means that they are corresponding angles. So I'm going to put angle 2 and angle 4 are corresponding angles, which means that if angle 2 is 95, angle 4 has to also be 95. So I say that 2x minus 17 has to equal 95 degrees, and then I can just solve. So if I add 17 to the other side, 2x has to be equal to 112. And then if I divide by 2, that is 56 degrees, I think, or x equals 56. Okay, so by corresponding angles, I'm able to say that those two things are the same. Okay, all right, I'm going to erase so I can do part B. Part B, find y if the measure of angle 3, this one here, is 4y plus 30, and the measure of angle 7 is 7y plus 6. Okay, so angle 3 and angle 7, what do those have in relationship to each other? They are, here's my transversal, okay? They are on opposite sides of the transversal, so alternate, and they are interior angles because they're on the inside of this little lane right here, okay? So 3 and 7. So when they're alternate interior angles, that means they're the same measure. So I could say that 4y plus 30 has to be equal to 7y plus 6. And then I just solve. So I'm going to subtract the 4y, and I'm going to subtract the 6 at the same time. Okay, so 30 minus 6 is 24, and 7y minus 4y is 3y. And then last, I'm going to divide by 3, and 24 divided by 3 is 8. So y is going to be 8. Okay? All right, the last thing that it gives to us says that if I have two parallel lines, this is the perpendicular transversal theorem. If these two lines are parallel and I have my transversal that goes through them, if this transversal is perpendicular or makes a 90-degree angle with the top line, it's going to also be perpendicular to the second line because those lines are parallel. Okay, kind of think of this as a ladder, right? If these two things going across here, and I have, you know, the vertical part of the ladder, if it makes a 90-degree angle with the step of the ladder, it's going to also make a 90-degree angle with the next step of the ladder. That's just kind of the way that it goes. Okay, so there was a lot of examples there, a lot of information. Hopefully all that made sense. We're going to hit this pretty hard on Monday and go over those again and do kind of a little exercise with that. Okay.